So let's talk about shredding now. Shredding is a way of basically creating these licks of flame. It's most noticeable towards the end of the flame's existence. And if you ever watch fire, especially towards the top, it kind of flicks outwards right before it dies. So towards the log section, you might have a really smooth looking body of flame, but then when it reaches the top, it just begins kind of flicking around and then it disappears. Shredding will give you that particular behavior. And this works by a combination of squashing and stretching. So we're affecting the velocity, which is the direction in which our voxels are moving, right? Or the voxel values are moving. And what we're saying is that squashing moves the flames outwards in all directions except for the y direction. And stretching stretches the flames in the y direction. So the combination of those two things is going to give us that flicking effect. Now, how do we tell the shred node which areas to squash and stretch? Because that's really the key to using this shredding node. Well, we'll use the temperature field to do this. And specifically, we're going to specify something called the temperature threshold. And that's like the midway points where something that was stretching is going to start squashing. So we start off by stretching and then we squash it out, and that'll flick the flames. So the areas above this temperature threshold will squash, and if you get below the temperature threshold, then it will stretch. It's way easier to see this visually. So let's say that this is our temperature field, and we've specified a temperature threshold of 1. What that means is that any areas in here that are red, those are temperature values that are 1 or greater, and because of that, these are the areas that will stretch. In other words, go upwards in the y direction. The areas that are squashing are all the areas that are not red. They're below this temperature threshold. So these are the areas that are squashing, and these are the areas that are stretching. Hopefully that really helps with this understanding of the shred node, because it definitely takes a minute to figure out at first. Let's now try to apply this to our flames. We've already combed them upwards in the y direction, so in a way we've already stretched out these flames using temperature and the velocity as a result from temperature. So the main thing that we want to do now is control this upward motion by squashing the flames towards the top. And that's exactly what we'll do here in a second. As always, it's great to look at reference and get an idea of where these flames are really starting to flick out and end their life. That's what we're trying to figure out. So if I was to draw over the main body of the flame, I would say that perhaps 50% of the actual flame body is just moving upwards in the y direction, kind of like these guys down here, if you can see my mouse, kind of like over there. See how they're going in the y direction? If you look at the main flames here, I'd say about half of the flame is doing that, and then the other half, once it reaches the top, is flicking out. So whenever we're trying to figure out this temperature threshold, we want to find that value which captures half the flame in a stretch zone and half the flame in a squash zone. I'll show you what I mean here in a second. Back here at the DOP level, be sure that your voxel size is something coarse. I have mine at 0.015, and then create a gas shred node. We'll plug that in to the very last input of the Pyro sparse solver. That is the forces input. So we'll do that. And right away, what you'll notice is that our fire looks a bit fuzzy, which isn't right. You know, fire doesn't really get fuzzy. Anytime you see that fuzzy fire looking effect, it's most likely because there's way too much of the shredding going on. And, well, it'll ruin the whole effect if you let it. So don't do that. What we want to do first is figure out that temperature threshold, that middle ground point between where it switches from squashing and stretching. So let's go and actually detach this here for a second. Go to the smoke object and let's turn on this temperature preview. We'll go forward to, let's say, about frame 60 once the simulation is warmed up a little bit. And then we're going to play around with the preview on the temperature plane right here so that we can figure out visually where that in-between point should be. Okay, so temperature, let's say our plane position is right there, right at a body of flame. Let's turn off this visualization right here. And now I'm going to go to this temperature tab, and I'm going to take this guide range from 0 to something else. So if we bring this down, you'll notice that I'm introducing more red. And what that's basically saying is, okay, anything that's red, again, is going to stretch. Anything that's not red is going to squash. So by adjusting this value, you can visually see where things will eventually stretch and squash. So let's say that maybe a value of 0.4, 0.5 or so seems to be the right spot. We'll say 0.4. Plug in the gas shred again. Go here. We'll say temperature threshold of 0.4. Now, if we go forward a few frames, we still have that fuzzy problem, but, and you could really see it here in the temperature, but let's bring back our multi-field again, and we'll just take the scale to something like 0.1 to start. It's still going to be too much, but we want to bring it down to something that's at least a little bit more reasonable. So there we go. Now at least we have a semi-reasonable thing going on here. The next thing that I'll do is I'll bring down this clip gradient. I'm not going to get into what the clip gradient does on a technical level here, but just know that if you turn down this value, you will essentially turn down the effect. So it's kind of like you have scale here, but this acts as another way of scaling the effect in general. So let's, instead of 7, let's say maybe 2 on that. Turn it way down, and maybe even turn our scale to 0.15. So we'll do something that's about that. I'm just kind of making up these numbers for right now. And then eventually, once we have an area that's looking fairly decent as far as that goes, the next thing to do is to adjust the proportion of squash and stretch. So right now, for every amount of squash, we have about half that amount in stretch. So I'm going to bring the stretch down to about 0.15. I'd recommend keeping the squash and stretch values between 0 and 1. So think of this as a proportion of one another. One squash is only worth 0.15 stretch. There might be a way of thinking about it. So maybe we'll say 0.2 and 1, like that. So we're mostly squashing here. And then let's just turn up this clip gradient a little bit more. We'll say 3 right there. And this temperature width is basically like a blending zone. So right where the squash and the stretch switch, they gradually switch over. And this temperature width is the area plus or minus the temperature threshold that it's going to blend between that squash velocity into the stretch, or between the stretch velocity going into the squash velocity. So temperature threshold, let's say this will be, instead of 0.1, 0.05, about half of that. And I think this will dial it in really well. Now, I know that was just a ton of information I just threw at you. Just know that the most important thing is defining that temperature threshold, specifying the scale correctly, and you'll find your main scale up here, and then you can just dial it in more finely with this clip gradient down here, and then figuring out how much squash versus stretch that you want. If you dial in the settings just like I did right there, then this shred is going to look totally awesome. And I think right away, especially look towards the top of these flames, you'll notice that that is a huge improvement to where we just were before. We still have a fast motion going upwards with that temperature, but now we don't have that straight, narrow, coned looking fire. We're breaking up that movement, especially towards the top here, and it's way more convincing that way. Okay, well, I'm going to now cache this out at a higher resolution. Let's see what that gives us with a flipbook, and then we'll perhaps dial in a couple more settings here and move on. And after we cache out something that's a little bit more high resolution, we end up with this. And this is a massive improvement to what we just had before, especially towards this section right here. Notice how we're just kind of flicking things out before it dies. It's a nice spot for that sort of motion to begin happening. It's not happening too early, which is right next to the logs. We still have these smoother flame behaviors down here, but that's exactly where we want that squashing effect, and it makes a huge difference. So there you go. That is the basics of shredding.